Hello everyone, welcome to Homework Help. If you find the video useful, please subscribe to the channel. In this video, we'll solve this word problem using a trigonometry model. As per the problem, a wave generator in a wave pool completes 20 cycles every minute to produce waves measuring 1.2 meter from the top of the crest to the bottom of the trough. In the first part, we have to model the displacement d in meters of the wave from the mean pool level as a function of time in seconds. So let's start with the first part. It will be easier to write the equation for displacement d if we sketch the given information. That will help us visualize the given information. Let's assume the mean pool level is at 0, the origin. As per the problem, the waves measure 1.2 meters from the top of the crest to the bottom of the trough. That means the amplitude of the waves is 1.2 divided by 2, which is equal to 0.6. So the maximum value for this function is 0.6 and the minimum value is negative 0.6, the bottom of the trough. Next, we can calculate the period for this function. As per the problem, 20 cycles are completed every minute. For the model, the unit of time should be seconds. That means the wave generator completes 20 cycles every 60 seconds. Period represents the length of one full cycle. In this case, we have to find the seconds it takes to complete one full cycle. For that, we should divide 60 by 20. Which is equal to 3, and the unit is second. So the period is 3 seconds. When the first wave starts, the water level is at the mean pool level. So the starting point of the first wave will be at the origin or 0. That means the first cycle will end at 3 on the horizontal axis. Since the mean pool level is at 0, that means the equation of axis or C value is equal to 0. That means the equation of axis is y equals 0. We can assume that as the first wave starts, the water level first goes up, then comes down, and then goes all the way down to the bottom of the trough, and then goes back to the mean level. So we can use sine function to model the displacement. The general equation for a transformed sine function is we have to use variables d and t as given in the problem. Now we can find the values of a, k, d and c to write the equation of the model. As per the sketch, we can use the positive sine function. So a is equal to the amplitude, which is equal to 0.6. We can find the k value from the formula for period. The period is 3. We can cross multiply the k to the left side. Next, we can divide both sides by 3. I get k equals 2 pi over 3. Next, we can find the d value. For this model, d value, which also represents phase shift, should be equal to 0 because we are using the sine function for this model. C value is also equal to 0 because the mean pool level is at 0. Now we can sub in these values in the general equation to write the equation of the model. T minus 0 is equal to just t, and the other 0 goes away. So this is the final answer for the model of the displacement d. Now we can answer the second part. If the speed of the wave generator is increased to 30 cycles every minute, what would change in the waves? In the second part, the speed of the generator is being increased from 20 to 30. As a result, more waves will be generated per minute, so the period of the waves will decrease. As per part 2, 30 cycles are completed every 60 seconds. We can find the period for this new situation by dividing 60 by 30 because period represents the length of one full cycle. I get 2 and the unit is second. So the period has decreased from 3 seconds in part 1 to 2 seconds. As a result, the k value in the equation will change. We can calculate it using the period formula. The new period is 2. We can cross multiply the k to the left side. I get k equals pi. The other values a, d and c will not change. So the new equation will be this should be the final answer for the second part. So these are the steps you have to keep in mind to solve a problem like this one. I hope you'll find this video useful. Please share it, like it and subscribe to Homework Help. Thank you very much and have a nice day. Bye.